Thank you.
Okay, thank you. Good morning to you all. The respected chairman of the Department of Economics and the Dean of Faculty of Arts, Professor Rangappa sir, Dr. Uchegowda, Suchitra madam, and other faculty members of the Department of Economics, Davangere University, and my friends and all the participants. In the last class, specifically the yesterday's class, you have been learned the time series econometrics or time series analysis. Before 1980s, there was a disopinion among pure time series analysts and econometricians, because the time series analysts believe in predicting or estimating or forecasting a time series variable based on its own past values, or the historical information has been used to estimate and predict the value of the variable, and there was no any theoretical background for those pure time series models. And whereas the econometricians, in specification of an econometric model, they built an econometric model purely on econometrics foundations, like a dependent variable is, for example, y. So then all dependent underpinnings. But after 1980s, there was a convergence in the opinions of econometricians and pure time series analysis. The econometricians made use of the time series concepts, or in other words, they made use of the lagged values of the variables as independent variables, along with the relevant other explanatory variables. And same is also true in case of time series analysis, or the pure time series analysis. They make use as economic theory in predicting or forecasting in economic varies analysis. Econometrics analysis, time series econometrics analysis, two purposes for which the time series has been used. One is for dynamic analysis, the other one is for forecasting analysis. I think what Prem Kumar has discussed in yesterday's class is related to dynamic analysis regarding a time series. So that means related to analysis and the problems
Sure. One.
Hello. Okay, sorry. Because of network problem, so we have a few minutes connection problem. So can you hear me?
Yes, sir. We can hear you, sir.
Okay, okay, okay. Sorry for 1 minute.
Yes, sir.
So, okay, well, okay. The second most important purpose of the time series econometrics is to predict or forecast the future value of a chosen variable, and that is the topic for our discussion today. Since we have only 1.5 hour time to discuss on the forecasting of the economic variables in particular, or the forecasting a time series variable in general. So my discussion is very brief. Okay, and here my discussion or this lecture that includes only the crux or the gist of the forecasting of a time series variable, because there are different methodologies which have been used in practice to forecast a variable, and out of that several methods of forecasting, the one more popular method and widely used method, especially in applied econometric analysis, was developed by Box and Jenkins. And that Box and Jenkins made use a ARIMA procedure to forecast and so estimate and forecast a time series variable. So hence, my lecture is mainly focus on a methodology developed by Box and Jenkins to forecast a single variable, a univariate time series variable. Because in forecasting analysis, so we have a univariate forecasting analysis and a multivariate forecasting analysis, and this ARIMA modeling is just forecasting the value of a variable in the future periods by using only single variable. But if we want to forecast a group of variables, so we cannot use this ARIMA modeling. And of course, our modeling should be based on the VAR, that is the vector autoregressive type of modeling, and based on that we can forecast a set of variables or a group of variables. Hence, my discussion is not related to that multivariate or multivariable forecasting methods. It is only related to a univariate forecasting method by using Box and Jenkins method, and or in other words, it is ARIMA procedure or ARIMA modeling. And this is a overview of the contents which my lecture includes: introduction to the ARIMA model, then assumptions of the ARIMA model, ARIMA models, because there are variants of ARIMA models. So we should have to have a knowledge on that variants of ARIMA models, and the procedure for by making use of them, and the methodology developed by Box and Jenkins. Okay, and also at the end, if the time permits, I will also show you how to do all these things by using Stata, one of the statistical software which I have of course used in the previous class regarding my logit and probit model analysis. So let me start my discussion with introducing this ARIMA procedure or introduction to ARIMA. Uh, as I mentioned earlier, the best best predictor of a time series variable according to time series econometricians or time series analyst is the two elements. According to them, or the two elements. The one is its own value in the past period. The second one is the shocks that has persistent for a longer period influences on the current value of the chosen variable. So, or in other words, very simply, the current value of a variable that depends upon its own past values. Today's consumption expenditure influenced by the previous levels of consumption expenditure. Previous periods might be monthly, quarterly, or annually. Or the GDP of India in 2020 determined by the GDP of India in the several previous quarters or in several previous years, past years. That means GDP is a so if the GDP is represented as Y, so then Y is equal to YT minus 1, YT minus 2, YT minus 3, and so on. Where YT minus 1 is the GDP in 2019, YT minus 2 is GDP in 2018, and so on. So which means that so the current value of a variable depends on its own past values. So those past values in econometric terminology are known as the lagged terms, the lagged elements. And by including that lagged elements, the past periods into our econometric methodology or econometric analysis to measure the influences of that past values, past periods information on a current value of a dependent variable. That relationship is known as autoregressive. And I hope in case of say the random walk models and testing the stationarity or a non-stationarity or a unit root in the previous classes of Prem Kumar, I hope you have been already learned that concept of autoregressive. So that's why. So according to time series analysis or the time series analyst, so one of the best predictor of or estimate of a variable, a time series variable, is its own past values or the historical data. Okay, historical data. The second one is, as earlier I have mentioned, is the shocks to the dependent variable. We know that, and of course, in general, simple analysis of specification of an econometric model or a regression model, that the last element in our regression equation is called as error term or the disturbance term. That error or the disturbance term is, in case of time series analysis, is considered as the shock variable. So if there is any shock to that particular variable, that shock might be because of the variables which have been included in the model, or the shocks outside the model. They are all represented by that disturbance term or the error term, u in our regression model, or the epsilon in some other representations. So hence, why the the dependent variable, that is, for example, why that varies, changes, or how it determines in the current period, it is also determined by, influenced by the shocks related to that variable. So hence, here we have the two elements, two factors according to time series analyst determine the current value. The one is its own past value. Its own past value means your chosen time series variables past values. The second one is shock to the your chosen variable. So in these discussions are the contents thus far I have been discussed. There is no economics comes here. Economics comes here means so you have not been used any theory in specification of this model. That means this GDP depends upon gross capital formation or gross consumption expenditure or foreign direct investment. So those econometric or economic background is not coming to part in determining this time series modeling, pure time series modeling. So hence hence here we have two components. The one is the past values of the dependent variable, and the other one is shocks to the dependent variable. So we have to incorporate these elements in predicting, forecasting, or estimating a single time series or a univariate time series. So this is the crux in case of this the ARIMA models or AR model, MA model, ARIMA model, ARMA model, and the final version of the configuration of all these is the box Jenkins model or ARIMA model, autoregressive integrated moving average model. So let us have a brief discussion on this specification of ARIMA, and discussing what is autoregressive in there, what is the meaning of integrated concept in there, and moving average. So hence this ARIMA is an acronym for autoregressive integrated moving average. Autoregressive, okay, it is autoregressive integrated moving average. That is A stand for auto or regressive, I integrated, M is moving, then A is again the average. And yes, we were noted that it is a prediction model used for time series analysis, and also I have told you that this ARIMA model is a model for only univariate prediction, univariate forecast of a variable. And we need not get into the meaning of time series, the definition of the time series. Already you have been, I think, learned this from last classes of Prem Kumar, and we are able to give the large number of n numbers of examples of a time series in economics, because of database management, and because of application of computer, due to because of this age of information. So today, so we have plenty of information related to most of our economic variables for a large period of time, and hence in literature that is called as we have an ocean of information. So ocean of information. Hence the information is not scarce today, because of in 1980s or before 1980s the information was scarce, so information was limited. But there is no limit to information today. So because of the advancement in computer technology, so because of that, so we are able to get information for most of our economic variables for very long period of time. And also we are able to get information for especially financial variables every day, every hour, every minute we are able to get. And of course that kind of information in econometrics, that is related to financial econometrics, I hope in the next class Niranjan will talk on that concept of the high frequency data. For that high frequency data, so we need separate econometric modeling procedure, so that is the financial econometrics related analysis. So because of this revolution in computer technology, especially in information technology related to collection of the information, so there is no question of scarcity of data, scarcity of information. So because of this reason, I hope in recent years, so this time series econometrics gaining much importance compared to before 90s or 1980s. So this is of course the what do you mean by ARIMA, autoregressive integrated moving average. And in pure time series analysis, and in your statistics classes, I hope you have been noted the components of a time series. So why a time series is volatile, why a time series is fluctuate, why we observe the variations in a selected variable. We know that there are four important components for that, like trend component, cyclical component, seasonal component, and irregular or random random components, and of course our discussion is not related to those components and modeling those components in our analysis. Okay, and as just I have told you that this ARIMA is made up of three elements. One is AR, the second one is ME, and the third one is I, autoregressive, moving average, and the integrated. As just I have told you that, so the AR in that ARIMA is related to regressing your chosen variable on own lagged values or the prior values. So you should have to take the past values, the previous period values of your chosen variable as independent variables. So if you regress yt, for example, on yt minus 1, yt minus 2, yt minus 3, and so on, that is called as auto regressive form. Auto regressive form. The second one is moving average. It is also a regression where the error representing the linear combination of the error term of the repeated values. So there also you have to take the error as a dependent variable and run a regression on that error dependent variable on its own past values, its own repeated values or the past values. So hence auto AR term in this ARIMA model, AR term in this ARIMA model is related to running a regression on its own previous or past values, whereas the moving average is related to again run a regression model on the disturbance term, error term, or the shock representation in your regression model on its own past values, that is the moving average term. The third one is, we need not discuss much about that third element, that is integrated of order or integrated. So you have in-depth discussion in yesterday's class related to stationarity and non-stationarity, and how to overcome from that problem of non-stationarity. I think in depth Prem Kumar has been discussed on that. So that means, so one of the most important problem of a time series or an econometrician faced in using the time series variable is the problem of non-stationarity. If there is a non-stationarity problem, we know that our results are spurious, meaningless, nonsensical. So to avoid that problem of nonsensical, meaningless, spurious relationship among our chosen variables, due to because of non-stationarity, we need to convert our variables into stationarity before using any time series variable, either for forecasting or even for dynamic analysis. And of course, as I've just mentioned, you have learned in depth that related to the stationarity or non-stationarity in the previous class. That's why in this ARIMA procedure, you should also to check whether your chosen variable is stationary or non-stationary. And from the previous classes, you have noted that if your variable is non-stationary, you should have to convert your variable into a stationary variable by taking differences. So here also we follows the same procedure of taking differences to convert our chosen time series variable, which has been selected for us to estimation of ARIMA model, before using it for the ARIMA procedure. So hence in ARIMA procedure or in ARIMA model, there are three elements. The one is autoregressive term, the second one is moving average term, the other one is integrated term. So this is a discussion on the elements of the ARIMA, AR, MA, and integrated order. And of course, there is this concept is so vast. That is, ARIMA modeling is so vast. And as I have mentioned, that this is just fundamentals of that, just an introduction to ARIMA methodology, ARIMA modeling, because we are able to also incorporate the seasonal dynamics into our ARIMA analysis, but that is not part of my discussion. So it is only non-seasonal ARIMA model, non-seasonal ARIMA modeling. So if you want to include the seasonality in your forecasting, because we know that within a year, due to because of the different season, or due to because of weather, due to because of other reasons, due to because of traditions, custom, and so on, some of the variables are vary or changes accordingly with that particular season. So if you want to incorporate that seasonality in forecasting using a ARIMA model, you have to use ARIMA model, that is seasonal autoregressive integrated moving average model. But this is a non-seasonal ARIMA model, so which can be classified as, written as ARIMA PDQ. ARIMA PDQ. So where the P represent, it is the number of the autoregressive terms. So earlier I have told you that this autoregressive term in ARIMA model represent the influences of the past values of your chosen dependent variable on the current value. But the question is how much or how many of your past values should be included in your model, whether it is one period, 2 periods, 3 periods. So, and of course it is a trial and error method. So hence you should have to decide an appropriate number of lakhs. Actually it is called in econometrics appropriate number of lakhs. So hence the first element, autoregressive term, it is represented by P, the number of the autoregressive terms used in ARIMA modeling. The second one is D, that is the number of the differences needed for stationarity. Some of the economic variable become stationarity by taking only one difference. There are few economic variables we need two differences, and based on the empirical works. So the most of the econometricians have told that or mentioned that. So for our economic variables, so we needed only two differencing. Majority of the economic variables, one difference is enough to make our non-stationary economic series into stationary economic series. So but in case of this ARIMA model, what this D represent here is the number of the times you required to transform or to convert your non-stationary variable into stationary variable. For example, if you have taken only one difference to make your non-stationary variable into stationary, then you should have to write one instead of D here. So if the P you have taken two autoregressive terms, that is the two period lagged values in determining the current value of the dependent variable, then the P becomes 2. If it is only yt minus 1, that is one period, it is 1. So then the last one is related to the shocks or the moving average terms. You have to use, that is the number of the lagged forecast error in the prediction equation. So that is how many numbers of the lags values of your disturbance term have been used here. If it is you have only used et minus 1 or epsilon minus 1 or ut minus 1, then it is 1. If you have 2, it is 2. So that's why in this modeling of ARIMA, you should have to determine so the order of P, order for I, and order for Q, or order of AR and integration, and the Q, that is the moving average. Okay, moving average. Then there are two assumptions, of course, in use of this ARIMA modeling analysis. And as of course we have noted that the variable which we have chosen to forecast or to predict should be a stationary variable. And already we have noted what you mean by stationary, a stationary series. And the stationary series has to say meet the three important conditions. One is the mean reversion, the second one is the time invariant variance, and the second one is the third one is related to the covariance of the two sub periods of your chosen variable. That should not be depends upon the time, but that should be depends upon other factors. So that is the covariance of the two sub periods should be equal to 0 or constant. That is the third condition. I hope the Prem Kumar has discussed in depth related to that conditions for a stationary variable. And in use of this ARIMA models. So we should have to assume that the variable which have been used for our forecast should be stationary. So then if I have told you earlier that if your chosen variable is non-stationary, you should have to make that variable by stationary by taking difference. So this is the most important assumption. So which you need to bear in your mind or note in use of these ARIMA models. Okay, so this is assumptions. So now earlier we have noted that this ARIMA model consists of three elements: autoregressive model, moving average model, autoregressive model and moving average model, and integrated order. So that integrated order is just a concept which is related to stationarity or non-stationarity. But the next two are AR and MR. We have a separate equations, econometric equations or specifications to represent that AR and MA terms. So the first is related to AR term. Okay, AR term, and as I already told you that there are different orders for this AR term. So AR1, AR2, AR3, or AR0 also. That means there is no, the current value is not at all depend upon the past values. Then AR becomes 0. AR1 means so only one past value, that is the immediate past value of that dependent variable influences on the current value, then it is AR1. So if both AR1 and AR2 have been included, that is called as AR2. That means so you have included the effects, or your intent to measure the effects of the past two periods on the dependent variable, that is y, or the current value, or the current value of your dependent variable. So that's why that order of, as we already noted, the order of the autoregressive model is represented by p order. It is the p order for the order 1, for example, that has been represented or mathematically written as x. Here x is a dependent variable, your chosen time series variable, that depends upon like this, that is xt is equal to eta xt minus 1. That means you have taken only one period past value of the, or the immediate value of this t or xt, immediate value of the xt plus epsilon t. This is the, this is the disturbance term of this AR model. Disturbance term of this AR model. So this is called as AR1 model. AR1 model, or in terms of ARIMA, you should have to specify that model as AR100. AR1 represent, you have used t minus 1, one period lagged value. The next element is 0. That means you have not taken, you have not taken difference the series, or you have not at all difference the series, because originally your variable is stationary. Okay, then the last 0 in this within the bracket is related to moving average. So that means you have not, that's why the in ARIMA it is called as AR100, or simply it is AR1. So then the specification of the pth order of autoregressive process, it is xt is equal to theta 1, xt minus 1, and xt minus 2, and so on, xt minus p plus epsilon t. So that means as many as the order of autoregressive, okay, autoregressive terms you can take, hello, can you hear me?
Hello, sir.
Okay.
Sorry, sir. Again, we have a problem, network problem. It's okay.
So ಸ್ವಲ್ಪ ವಾಲ್ಯೂಮ್
So
ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಮಾಡಿ.
are you seeing screen?
No sir, no sir.
No, no. Okay, okay. Then now
Okay sir, it's okay
can you
sir.
see? Okay, okay, okay. Then the first is moving average one. That means you have included only the immediate period. The error term are the epsilon t minus 1 into your regression equation, and assume it to be that influences on your chosen dependent variable, that is the time series xt, and that is called as moving average 1. And it is the q moving averages, that is the qth order. Qth order, you can include any number of the order of this q, similar to your AR terms. But if a time series that determined by both the AR terms and the MA terms. So, and in other words, if the XT is influenced by both the past values of its own and also the past values of the shocks or the error term, then you should have to combine it. You should have to combine it. By combining the AR and MR terms, AR and MA terms, so then that is called as ARIMA model. AR, MA model, that AR, MA model with P and Q orders. With P and Q orders, the earlier two equations are subsumed here, or combined here. Combined here, the first part of this equation is related to the AR terms, the second part is related to the MA term. So the reason for this ARMA, that is AR and MA, is as just I have told you that. So if the chosen time series variable is not only influenced by its past values or the previous periods, and also the shocks are assumed to be influencing on the current value of a chosen time series, then you should have to club these two and return a ARMA model, a ARMA model, by using this mathematical representation. So this is AR model, MA model, and the ARMA model. And the ARMA model, to summarize on this AR, MA, and ARMA model. So AR model only includes the influences of the past period on the current value of the time series variable with different lags values. Then MA, that represent the effect of the shocks, which is assumed to be persistent for the longer period on the current value of a variable. Then we should have to model and include that shocks in terms of the past values of the disturbance term into our model, where the dependent variable is again xt. And if a chosen time series variable influenced by, determined by both the past values of its own and also the shocks related to that particular variable, so we have to combine both the ARMA, that is called as ARMA model, and that is ARMA model. ARMA model. And earlier I've told you that you can have any variants of this ARMA model. So ARMA 101, ARMA 101 represent, you have taken only one autoregressive term, one moving average term without difference, or ARMA means one autoregressive term with difference. There is no moving average term. That's why you can have a infinite orders of this ARMA model. Out of that, you should have to select one appropriate for your estimation. Then how that appropriate model as to select for our analysis, we will come to that part later. We have to come to that part later. So then earlier I have told you that. So we know that so a dependent variable or your chosen time series variable not only influenced by its own past values and shocks. There are some other relevant variables, other independent variables assumed to be influenced on a dependent variable. So if you want to include that independent variable or explanatory variable or a covariate into your model along with this AR and MA terms in this ARIMA model. That model is called as ARIMAX. That is ARIMA plus X. X represent a variable that influences on the current value of a dependent variable other than AR and MR terms. That's why it is ARIMA plus X. For example, one an environmental variable is important in case when the external variable starting the series. Flight. One example is flight delay prediction depends not only on historical time series data, but also external variables like weather condition, that is temperature, pressure, humidity, visibility, arrival of the other flights, waiting time period, and so on. So if you take, for example, prediction of GDP, then GDP not only influenced by its own past values and shocks to the GDP, but also by the gross capital formation, foreign direct investment, and research and development. So and trade. So these variables are X. So if you include these variables into your ARIMA analysis, then that is called as ARIMAX. But our discussion is not of course related to that ARIMAX analysis or using this ARIMAX methodology. So our discussion is a fundamental, since it is a fundamental in nature, it is only related to ARIMA model. Okay, this is of course the basics of ARIMA. So to sum up the contents thus far we were discussed. So one of the most important out of two purposes of use of time series analysis is forecasting. The other one is analysis, and more specifically dynamic analysis. So then there are of course different methods of forecasting even in statistics and even in econometrics. Out of that, different variants or the types of forecasting, the most popular and widely used method is ARIMA model or autoregressive integrated model, which has been developed by the two statisticians. They are called as they are Box and Jenkins. Hence, this ARIMA procedure or the methodology is also known as Box-Jenkins methodology. So this ARIMA model consists the three terms. The one is AR, the second one is high, the third one is MA. Okay, the AR term is related to autoregressive, I is integrated, and the MA is moving average. Moving average. So the first term, AR term, that the AR term uh, or, or the inclusion of this AR term into this ARIMA modeling is, it is assumed that the past values of a dependent variable is the best predictor of a dependent variable. Hence, the AR term has been included. And the moving average, the shocks to that your chosen time series variable also influences on the current value. That is, any shocks in the previous period that influences on the current value of a dependent variable. So hence that moving average term has been included. And we know that after and of course because of the works of Nelson and Plosser, I hope these for economic variables have a problem of non-stationarity, because they have conducted a study selecting 14 macroeconomic variables in America, and they have found that, or their study found that out of 14 variables, 12 variables were non-stationary. But before the works of that Nelson and Plosser, so the econometricians were not serious about the problem of non-stationarity. So hence, so since we are using a time series variable in our analysis of ARIMA, so we need to also check that stationarity, whether our series is stationary or not. If it is our chosen time series variable is a stationary, your forecast is not valid, your forecast is not reliable, and it is spurious, meaningless. So hence the next the I term has been included, or integrated of order term has been included into this ARIMA analysis. So and that is the basics related to this ARIMA modeling. So now let us come to how to model this ARIMA. How to model this ARIMA, or identification of number of AR terms, the number of integrated terms, and the number of moving average terms. As I already told you that it is a so cumbersome procedure, and it is a trial and error method. So you cannot directly obtain in appropriate numbers of AR, MA, and integrated terms. We should have to go through a trial and error procedure for that. So even today, with all applications of say the econometric softwares, but that econometric software made that the trial and error method easy compared to a manual method earlier, which was followed. So hence, the second topic of our discussion is the modeling ARIMA model, or the procedure for ARIMA model. ARIMA model. The first is you should have to, you should have to ensure that your chosen time series variable is stationarity. Otherwise, you cannot continue for modeling or predicting and estimating, predicting and forecasting your variable. So then the next one is make correlograms, that is the autocorrelation function and partial autocorrelation function. And by making use of this observation of the correlograms of ACF and PACF, you are able to indicate or able to identify the number of the AR terms and the number of the MA terms from this ACF and PACF. So by observing the PACF, you are able to identify the number of the AR terms which are appropriate. By observing the autocorrelation function correlogram, you are able to identify the moving average terms. So that is AR terms and the MA terms. Whereas for stationarity, you know that, so you should have to check the stationarity by again ACF or by conducting any unit root test. I think Prem Kumar has been in depth discussed related to augmented Duque filler test or Philip Perron test or any such advanced test. So that is the first part, and the second is that. And once you have identified the appropriate number of AR and MA terms by observing the correlograms of ACF and PACF, so then you have to fit the model. That means you have to estimate the model by using the values determined by the second step. And the fourth one is you should have to do diagnostic test. That means whether your estimated RIMA model is adequate, that satisfy the assumptions are not. So that is related to diagnostic test. And the last but not the least is using that estimated appropriate model for forecasting, for the fitted model for the forecasting purpose. So these are the 5 steps which have been included in this ARIMA procedure. And of course, the same has been developed by Box and Jenkins. And hence, I already told you that this is called as Box Jenkins approach. And these are the steps earlier told you that. So you should have to make your variable stationary if it is non-stationary. That's why different one is you should have to identify the model. So identify, and also in terms of course there is not mentioned there in these slides, that is through by using information criteria. I say, might be you have heard about this information criteria that has been given by many of the statistical packages along with the results, are more specifically by of course EViews, that is SIC and AIC. That is AIC means archaic information criteria. SIC is squared information criteria. That is also called as BIC. That is the Bayesian information criteria, and HQ criteria, log likelihood. So these are the different information criteria which have been used along with that PACF and AACF to identify the model. That's why identification means you should have to identify the number of the P terms and the number of the Q terms. That is the number of the auto regressive terms and the number of the the moving average terms. So once the appropriate number of AR and ME are determined, then estimate the parameters of the model. And after that, as we are noted in the previous slide, diagnostic check, you should have to do that. And it is is the model adequate, is that is satisfy all the assumptions related to your estimates. So if it is yes, then use that model for forecasting. If your model fail to say meet the assumptions. So then you go back to identification, then select once again appropriate model, estimate, and repeat the same procedure. So this is called as the box Jenkins approach or ARIMA approach. So let us take this one by one in very brief form. And of course, I don't want to get into this part because already in the 2 hours class or the 2 sessions in the previous day or the yesterday, you have been discussed this. That is, so what is stationarity, what is non-stationarity, how to identify whether variable is non-stationary or not. If it is non-stationary, how to correct it by using differencing your series. And I think that they are all being discussed by Prem Kumar. Okay, that is related to the first step. Then the second step is you should have to use parallelograms. Earlier I have told you that as a second step to identify your ARIMA model. So one is autocorrelation function. Already we have autoregression. So by using that autoregression type of analysis, we are able to specify an autocorrelation function. So by using that autocorrelation function and representing this estimated value of the autocorrelation function into an autocorrelogram, we are able to identify whether the moving average order is 0 or 1 or 2 or 2. So I will show you like this. Okay, let us assume that this is the ACF graph, autocorrelation function graph, which we have been derived from this, and this is looks like this. And I hope Prem Kumar also has been shown this graph. So this is a graph which is also used for the stationarity or non-stationarity of a data, or to identify the non-stationarity of a data by observing this. So this is a non-stationary type of data. So hence we should have to take a difference of this, and by observing, okay, by observing the first difference of that non-stationary data, as I earlier have told you that the moving average, okay, has been selected. Moving average has been selected for that. So based on the spikes, for example, in this case, so it is, since it is an unstationary data, these are the spikes. So this is 95% confidence interval. So are the 95% confident bands, upper limit and lower limit. So the number of the spikes outside this 95 confidence band, that can be used as an indication for the inclusion of the numbers of the moving average terms from this ACF graph. That is the point. That's why the point which you should have to bear in your mind, by using ACF, you are able to determine MA. Okay, by using ACF, you are able to determine moving average terms. So how to determine that moving average terms? By observing ACF. So how many lines or how many spikes of this estimated ACF are out of this 95 confidence band. So which you should have to use in your ARIMA model. Okay, and in the earlier case, there are of course it is a separate diagram. If there is a 6 1, okay, 1 to 6 we should have to use here. Okay, for the earlier, for example, let us assume that we have run a GDP, okay, 1. So okay, variable. So how many are outside this? 1 2 3 4 5 and 6. There are 6 spikes which are outside this 95 confidence band. So then how many moving average terms you have to use? You have to use 6 moving average terms. So that's why by observation of the ACF, you are able to identify the lags of moving average. Then by observing the partial correlogram, so you are able to identify the AR terms. So AR terms, and this partial correlogram is simply a plot of extracting the partial autocorrelation of in the selected time series and within a 2 sub periods of the selecting. And I don't want to get into the technicalities of that, how it has been mathematically represented. You better to go with the literature for that, since paucity of the time. So the point which you should have to bear in your mind is that the partial autocorrelation gram or parallelogram has been used to identify the number of the ER terms. So let us here observe. This is the pack graph for GDP. So how many spike we have here? we have only one spike. So that means how many AR terms you have to include in your ARIMA model for this variable? Only one, only one. So, and all after this, they are cut off to zero or dies very quickly. So then since there is only one spike, there is only one spike in this case, okay, this represent you have to use only one AR term, one AR term. So that the same has been of course given in words in this slide, okay. By observing those ACF parallelogram and the PAX parallelogram or the PAX parallelogram, we have noted that our time series was non-stationary. That's why this is a summary of our earlier discussion. That means we have identified AR, we have identified integrated order, and also we have identified moving average. So by observing ACF function, autocorrelation function, earlier we have noted that how many spikes we have seen outside that band. There are 6 spikes are outside that band. That's why you have to include 1, 2, 3, 4, 5, 6. But we know that only one difference is enough for that particular series to make it as non-stationary from non-stationary. That's why your integrated order is 1, 1, 1, 1. By observing the PAX parallelogram, partial autocorrelation function parallelogram, in the previous slide, you have noted that only one spike is out of that band. So hence, the AR term is only 1, 1. So then how many models here you have? How many models you have here? By observation of that ACF parallelogram and the PAX parallelogram, there are 6. The first one is 1, 1, 1. One AR term, one differencing, and one MA term. Whereas in the second case, 1, 1 represents, since 1, 1 is for AR and integrated order, the 2 for moving average, 3, 4, 5, 6. So hence, there are 6 models have been derived from our PAC and PAC and AAC. That is the ACF. So then how do we have to decide out of this 6 model which one is appropriate? So for this, econometricians have developed some information criteria. They are called as information criteria. So by looking into that information criteria for these different models, because we have to estimate information criteria for all these 6 models and observe that information criteria of AIC and BIC. So out of these models, which model has the minimum value of AIC and BIC has to be selected as an appropriate model for your data or for your variable. So I repeat this. So by observing these packs or the ACF parallelograms, you are unable to decide. Which model is appropriate. So for that, we should have to rely on, or our decision should be based on, a concept called information criteria. So there are 2 most popular information criteria have been used. The one is AIC, archaic information criteria, and the second one is the bias information criteria. So you should have to calculate these two for every model, and you should have to observe the AIC of these 2 criteria. Which model has the lowest value of this AIC and BIC, you should have to select that particular model for estimation. So these steps are related to identification. That is the most tedious, cumbersome step in ARIMA modeling. But once you have decided an appropriate model, so then the method of estimation and the remaining aspects are automatically because easy for us to use statistical packages to estimate the results. Hence, the estimation is very simple. Once the model order has been selected means how many AR term are appropriate, how many differencing or how many differencing you need to take, and how many, so the Q terms are appropriate. Once you have decided based on the earlier step, the next is you need to estimate the parameters of that model, that is fit the model based on your AR and MA terms along with the integration of order or the integrated order. So that is very simple. That is the third step. So thus far we have noted that the first step is checking for stationarity. The second step is identification the model for AR and MA terms. So once the appropriate model has been selected, the third step is estimate this. Okay, once the estimation is done, the next is you should have to check the validity of your estimated say models, results of the estimated models. So there are different diagnostic tests has been used in practice. So you should have to observe the residuals related to your estimation, whether your residuals are white noise or not, whether it follows the normal distribution or not. You should have to check for that. And also again you should have to draw ACF and PCF PACFs for this, for your residuals. So whether that satisfies, or there, if there is no, or all the spikes are within that band, so then there is no problem related to that. And the last but not the least one is quantitative one, is the box Jenkins models related to Permonto test, or that is called as the Jenk box test, or the Q statistic, Jenk box Q statistic, Jenk box Q statistics. Yeah, so that is by using that one could use the box Jenk or the box Jenks or the Jenks box statistic to decide whether our estimated model is reliable or not, valid or not. So that's why, so we can diagnose this in three terms. One is by observing the normality test. Then the second one is about the ACFs and PACFs of the model estimated. Then the third one is, and most important one is, the Q statistic of the box and Jenks methodology. This is related to diagnostic test. The same of course given in this slide also. Okay, and the next is forecasting. Then once the model, of course, once the model is estimated, and by making use of the previous methods of diagnostic text, you can use that model for prediction. You have to interpret your results, and also you should have to check whether your forecasted values, okay, forecasted values are valid or not, whether they are reliable or not. For that also there are different say the statistics which are available in statistics. So this is a brief discussion on the ARIMA modeling, or the Box Jenkins methodology. Box Jenkins methodology. So to sum up on this the Box Jenkins methodology, or the ARIMA model applications, this ARIMA modeling or the Box Jenkins methodology includes 5 important steps. First, you should have to check the stationarity of your chosen variable. If your chosen variable or a time series variable is non-stationary, use to check for that, you should have to use the autocorrelation function or the unit root test to identify whether your series is stationary or not. If it is non-stationary, you have to convert that stationary your variable into stationary by taking difference. Okay, that is the first step. The second one is you should have to identify your model. Identification is related to the selection of number of ER terms and MA terms. So to select the number of ER and MA terms, you should have to follow two things. The one is graphical observations of autocorrelogram and partial autocorrelogram. The second one is information criteria, specifically archaic information criteria and Scratch or Bayesian information criteria. So that is the identification. So by making use of these tools, you have to select one out of the several models you have estimated as an appropriate model, and that is called as a selected model for estimation. So once the model is selected, then the third step is estimate the parameters of that model, and more specifically by using maximum likelihood estimation. Okay, so then once the model is, or the parameters of the model are estimated, then you should have to validate your results. That is, I have told you several times, is called as adequacy of the model, whether that model met all the assumptions or not. So in case of this ARIMA model, you should have to check whether your model satisfies the assumption of normality by using both the QQ plot, QQ plot, that is the normal distribution plot, or histogram plot, or by using some statistical test. Okay, statistical test for that. And also the second type of the validity or diagnostic tool is again you have to use the autocorrelation gram and the partial autocorrelation gram for your estimated values, whether there is any again some further spikes, but in this case there should not be any further spikes above or below that 95% band. Okay, then the third one related to the diagnostic test is Jenkins box statistic or Q statistic. So by observing that, you are able to decide whether the model is appropriate or not. Then the last but not the least is, so once your estimated model met all these conditions or it passes all the adequacy test, okay, tests, then you can use it for forecasting. So, and even within forecasting, there are in-sample forecasting, out-sample forecasting, and once the forecasted values are estimated or predicted, again you should have to check whether that forecast is accurate. So for such an accuracy of your forecasted value, there are again several tests are available. So that is called as forecasting error. I hope all of you have very well versed with that concept of forecast error, because we cannot estimate certainly a variable. Always there is a difference between your estimate and a predicted value or the forecast value. Okay, if that predicted and the actual value or the forecast value and the actual value is very less, then, or it is less than, of course, 5% in general, that is your model can be accepted. Your forecasted values can be accepted. Also, there are other tests to do all those things, like the tail test is one. So and also we can plot our forecasted value with the actual value. Observation of that also we can decide is there any deviations or not. So like this there are different again things which you should have used your estimated model. This is about okay, this is about a brief discussion on ARIMA modeling. So okay, well, I hope you have been understand what I have been discussed from last almost 70 minutes. As I have told you that this is just a introduction or the fundamentals of ARIMA model. So let me take one example to show you how to do all this by using a statistical package called Stata. Okay, Stata. I will take only one variable. So then how to use the Stata for doing, and that is the estimation and forecasting of that variable. So can I start a practical class?
Yes, sir, you can start, so no issues.
Okay. If there any queries or questions, let us have a 5-minute discussion after 12 o'clock. Okay.
Yeah, fine, sir.
Okay.
Hello, sir. Sir, thank you, sir.
Yes, really, sir.
Thank
Hello.
you. Very nice
Thank you,
presentation.
Thank you, sir. Thank you, sir.
Sir, sir, Uchagowda is in line. Inform ಮಾಡ್ಬಿಡಿ sir ಎಲ್ಲ. Just inform all the participants.
Hello.
Sir.
Sir, shall I continue with the practical class?
Okay, sir. Please, sir.
Yeah, please, sir.
Go try, huh? Okay, sir.
Continue
Okay, sir. On 15 minutes ಅಷ್ಟೇ.
Yes, sir.
Okay. Go to next class ಇರೋದು 12:15 ಗಲ್ವಾ?
Okay, 12:15 ಗೆ sir, ನಿರಂಜನ್.
Okay. Then I need another 15 to 20 minutes. That's all. Huh?
Okay, sir.
So, okay, well, as I have told you that, let me take one example for this estimation of ARIMA model. ARIMA model. For that, here package. So of course, hence I click on Stata and double click on that. The home page of Stata has been opened. Okay. So then, since I had my data not in Stata software, but it is in Excel file. I need to import that Excel file into Stata. And I hope that so you are all familiar with all these things of importing or exporting of files and so on. Hence I don't want to get into or much related, don't want to discuss much related to that basics of use of these statistical packages. So to import my data file which is in Excel, so the steps which we need to do are you click on file button. So who are not of course familiar with this, so you should have to write a procedure of using of this data. That means you should have to first write down file. Okay, then file. After file, a menu, drop down menu appears. In that drop down menu you have to select import because you are importing a file. So the type of the file which I need to import is a Excel spreadsheet because my data is in Excel. So then just select and click on this submenu. Then a dialog box opens. So in this dialog box, there are various things. So you have to browse your file. So for that, you have to click on browse button. And of course, since I already used this at the first time itself, my required work file appears here. Otherwise, you should have to search for that. So actually, it is in desktop. Within desktop, my file is in Davangere University class, and within that, I have one more folder. That folder, I have my data. Okay, you go on searching on that your required file. My required file is the workshop data, and you can give any name for that. Okay, you can also give ARIMA or whatever it is. Okay, so I need this file for my analysis. Just select this file and open this file. Just open this file. Okay, open this. Then the required informations are available. But in my Excel sheet, I have several sheets, or my data is in different sheets. My required data is not in the first sheet. It is, for example, in okay, it is India. It is a data related to Indian economy on consumption, income, and investment. Okay, income and investment. That's why I have selected a sheet which is required for me, or the data in the sheet which is required for me. Okay, so then after selection of that particular sheet, okay, particular sheet, okay, you should have to import first row as a variable, because already I have typed the names of the variables as the first row, or in the first row or the first cells of every column as the name of the variable. Import first row as a variable name. Okay, so after doing this corrections, or making this correction, you just click on this OK button. The data file your data is imported or not, as similar to your original file. Below the main menu, you have another menu below that. So this is a data editor. Okay, you just click on this data editor, that is look like your Excel sheet, and your data is imported. Okay, the three variables, income, consumption, and investment expenditure in India, okay, included in our data for the year of 1952. It is the last year of our period is 2011. Okay, 2011. So I need to, of course, delete these two. Okay, for deleting these two, okay, I have to re-click that. Okay, values. So where is it? Is drop the selected data. Yes, because two more rows are collected automatically, and hence I drop these two. Okay, so my the period of the study is from 1950 to 1960. Sorry, 2001. Sorry, 2011. So that is how many years? 62 years of data we have. 62 years of data. Just this is just for your confirmation whether your file has been imported or not. So once you have did this, okay, once you have did this, so you okay, sorry, okay, you close this file, okay, you close this file, you close this file, or this one, close this. So then this is the home page of the stata. Okay, home page of the stata. So in this home page of the stata, related to our ARIMA analysis, as we already noted that the first step is you should have to check whether your selected series is stationary or not. So out of this, the income is the GDP of India. Okay, I am checking, and of course I am here estimating and forecasting GDP of India. Okay, so then the first step is I should have to do I should have to do I should have to do whether this income is stationary or non-stationary. That is the first step. So hence let me okay, observe. Okay, let me observe first before, of course, giving any commands. Of course, here I am making use of command version of this data. You should have to, in case of stata, you should have to give a command. You should have to give a command, or you should have to tell this data you are using time series type of data. Because so whether you are using time series or cross-sectional or panel data, so or a survey type of data, so isn't that is needed to say, or that is required by this data software to use the appropriate tools. So in case of this data, you have to type TS set. That means we are setting a time series variable. So keep this point in your mind. So first you should have to type TS set. So then the time variable is the year in our case. This is the time variable is year in our case. Okay, the time variable is year in our case. So that is appearing here. Okay, that is appearing here. Sorry, because I need. Okay, so okay, here appearing here. So that's why you have to type under the command window as ts set here and press enter button. So once you press enter buttons, so you have mentioned that you have told, or you have give a command that so you are using a time series data which is yearly data. If it is quarterly, so you just type quarterly or monthly or daily, depends upon your periodicity of the data. Once you have set your data as a time series data, then I use autocorrelogram. Okay, autocorrelogram for the income variable or the income variable. So for that you just type AC income. AC here in stata is autocorrelogram for the variable INC, that is the income in our data set. After typing this, you press enter button. So once you press enter button, okay, your ACF comes like this. So that means it is
Sir, hello sir, my sir. Chetan, hello Chetan.
Sir,
Hello.
yes, sir. Chetan?
Hello, Chetan. Professor Gowda sir, maybe some network problem ಇರ್ಬೋದು ಅನ್ಸುತ್ತೆ ಸರ್ ಕಡೆಯಿಂದ.
Yeah, okay. Again, of course, sorry for inconvenience due to because of network problem.
No problem.
Okay,
That's fine.
okay. Then I have to. So okay. So then here I have taken the AC of INC, the income, AC of INC, that is income. So by observing this autocorrelation, autocorrelogram, so the income or the GDP of India is non-stationary. Hence, I should have to check whether it is stationary at the first difference or not. So for that purpose, okay, I should have to okay, again my change my or transfer income into first difference. Transfer income into first difference. So of course I need not to generate a new series of that. I can directly generate a new series and test whether that is a stationary or not. For that purpose, so you have to type AC, autocorrelogram, for first difference of INC. Okay, so the elements which I have just typed, you should have to read it as I am of course required autocorrelogram for first difference of INC. Instead you need a difference of a series, so you need not to generate a new series. Just type D, a dot, and the variable name. So that produces the first difference series autocorrelogram. After this, just press enter button. But here, even of course by taking this, but only two or three are like this. But approximately we can say that there is by taking the difference, the series is stationary. By taking the difference, the first series is stationary. Okay. So then like this, you should have to do or use autocorrelogram to check whether your series is stationary or not. Series is stationary or not. And also you have to use the unit true to test, as of course discussed by Prem Kumar in the previous class. I don't want to get into that part because I'm running out of the time. So hence the first step in this ARIMA model, you should have to test your series is stationary or not. That has been given hint by Prem Kumar, or make use the hint given by the Prem Kumar for that purpose. If the series is non-stationary, in most of the cases in practice it is non-stationary, you have to convert your series into stationary before estimating the ARIMA model. Okay, that is the first step. Then the second step is identification of your ER term and MA term. Identification of ER term and MA term. For identification of the ER term and MA term, AR term and MA term, you should have to say type first. You should have to so again follow that ACF and the PCF. ACF and PCF. Again I type here AC, then AC for D. AC for D INC, because earlier we have noted that your income is non-stationary. By taking first difference, it is stationary. That's why I am here using that autocorrelation or autocorrelogram of the first difference of the income for identification of moving average. Earlier I have told you in my discussion, the AC autocorrelogram is used to identify, to determine the moving average terms. So just enter button. So this is the 95 confidence band. Earlier I have told you that how many spikes or the lines are outside band. There are 3. So hence you should have to use 3 bands. Sorry, you should have to use moving average. How many moving averages you have to use? Moving average term, 3 moving average terms you have to use. 3 moving average terms you have to use according to this ACF. according to this autocorrelogram or autocorrelogram function. So this is the identification of MA terms by observing autocorrelogram. So then we close it and go to next command. So now you draw partial autocorrelation function to identify to identify to identify the AR term. So how to type or how to get to that partial autocorrelogram in Stata? PAC. AC is autocorrelogram. PAC is partial autocorrelation. Partial autocorrelogram. So for PAC, type PAC, give a space, then difference of INC. So then again press enter button. Press enter button. So you need not worry about the right hand sides of this. So at the first, only one term. Only so one so the three terms. Okay, only the three terms are again outside. The four terms are outside this. So the three are positive, one is negative. But let us here take the first three terms. So again for this income, there are three terms are outside that confidence bound of error correction. Here it is also 3. Here it is also 3. So that's why the MA term is also 3. So that means the appropriate number of appropriate number of lakhs or the order of this P is 3, Q is also 3 by this AC function and PAC function or autocorrelogram and partial autocorrelogram. This is the one. This is the one which is by observing AC and PACs. But as earlier I have told you that we have to use information criteria. We have to use information criteria. Akai can the Bayesian information criteria to also decide the that is the order of the integration. So and also order of the P and Q terms are integrated. That is the AR term and the moving average term. So for that, okay, for that you should have to estimate the different forms of your ARIMA model, different forms of your ARIMA model, and obtain the information criteria for everyone, and compare the information criteria for all the alternatives. So you should have to check that. For example, from the PAC, that the PACs and the ACFs, so it is 3 and 1 1. That's why you have to check 1. Again you should have to check 1 2 3 1, again 1 2 3, like that. You have, so you have totally again 3 models. Again you have 3 models. So out of the 3 model, which one is correct? You have to use information criteria for that. And even for the information criteria, through the information criteria also you are able to identify the order of the AR term and the order of the moving averages. For that, in the command window you have to type ARIMA. Okay, so then after typing ARIMA, okay, then the name of the variable you should have to type. Our variable is INC. So then after this, once again you should have to type ARIMA, and within the bracket you have to mention, for example, 1 AR term, 1 integrated order, and 1 moving average. I repeat. So in the command window, you are estimating an ARIMA model for a dependent variable income with a order of ARIMA 1 1 1. So after this, so you press enter button. So if you press enter button, since it is a maximum likelihood estimation, that takes several iterations, and finally it chooses a minimum value out of that. That is the log likelihood minimum value, and these are the results. So in this result, ARL1 MAL1 MAL1 represent AR1 term and MA1 term. They represent coefficient values. So for example, the estimated value of the AR1 is 0.99, which is very high. That means the the previous year's GDP or the income is highly influenced by the current year's income is highly influenced by the previous year, because it is very, very close to 1, and which is also statistically significant at 1%. But the moving average is insignificant. Moving average is insignificant. The value is negative and the moving average is negative. Indicates that, so there is a negative, the shock has a negative impact on the current value of the GDP or the income, and which is but which is insignificant. So I don't want to get into a detailed discussion on these results. So this is the way which you can interpret the results of estimated value and their probability value. So then let us change this one. So why, instead of 111, let us since the moving average is insignificant, just input there 0. So that is autoregressive order is 1, the integrated order is 1, but the moving average is 0. So then the results are as follows. The results are as follows. So that is only now we have AR1 term, which is statistically significant. And to obtain, for example, and compare these two models, for example, compare to these models. So let us, before you should have to estimate the information criteria. To estimate information criteria, you have to type like this: E stat. That means we need a statistic related to information criteria. So if I write your E stat information criteria and press enter button, that gives you information criteria of AIC and BIC. Earlier I have told you that this AIC and BIC is related to 110 model. Okay, so then if I need the AIC information criteria for also to the 111 model, after estimation of that, again you should have to estimate stat information criteria. This provides you information criteria for this model. So now check the AIC and BIC of this. The AIC of BIC of this are 996 and 1004, and compare this information criteria with the earlier model, 110 model. What is the value of that information criteria? They are 994 and 901. So by comparing these two, which one is appropriate? So the first one is appropriate, because in selection of the appropriate model of ARIMA by using information criteria, the point which you should have to bear in your mind is that, so the least value, the minimum value of EIC across your estimated model has been selected. So a model with the minimum value and BIC is the model which is appropriate for our estimation. So likewise, you should have to do all these manually, or in the sense you should have to estimate 110, 111, 011, and 201, and so on. So once you have do all these things, okay, so you can also at a time simultaneously you can obtain the results related to this information criteria like this. Okay, related to information criteria like this. That means you can E start. Okay, start. Okay, starts all the starts. That is the information criteria you have not we have estimated, and if space all. So that gives you the all the models. So that means that gives you E start all. That means, so in a single table, that gives you the compare simultaneously the AIC and BIC of a model. So this is about identification of the model. But again, because of the paucity of the time, I am unable to get into all those models. So this is the way which you should have to identify your model. That means you have to observe the autocorrelation gram or autocorrelogram for identify the moving average terms, PAX, that is the partial autocorrelation function and partial autocorrelation gram for identifying the AR terms, and a quantitative one is using the information criteria. So you should have to estimate several variants, combinations of AR and MR terms along with the integrated order, and obtain the information criteria from that, and you have to select the least value of the information criteria from your estimated models, and that is the model which is selected for your further analysis. That is for estimation. So this is about the identification. So once the model is identified, let us assume that my identified model is 110. Okay, 110. So then once it is identified, it is a ARIMA model of 110, which of course already I estimated. So for estimation purpose, once again you have to type ARIMA, then the D point INC, comma, again ARIMA, and my specification of the terms is 1 space again 1 and 0, close the bracket. So that means let us assume that by doing all these exercises, trial and error method, finally our work showed that ARIMA 110 is appropriate is for our model. Hence this model has been selected and has been used for estimation. So then for that estimation, you have to type this command in the stata and press enter button. And these are the results of that model, results of this model. These results earlier we were already noted that again, of course. So in case of using only ARIMA model, okay, ARIMA model. So ARIMA model, since already I have taken a difference of this, you need not to use your say 1 okay, 1 so this is the lagged error term, so it is negative effect. The previous one period past value of the G income on the current value has a negative effect, and also it is statistically significant. So this is the way which you should have to interpret the results. So this is related to estimation of ARIMA model, a selected appropriate ARIMA model from the previous step, that is say identification step. So this is about the first is testing stationarity. Second one is identification by using AC autocorrelogram and partial autocorrelogram and the information criteria. And then last one is estimation of the appropriate model. Okay, so this is about the estimation of ARIMA model. But to predict, okay, but to predict or to forecast or to predict, first you should have to type like this. So you should have to type a command like this, predict. What we want to predict, you should have to give a name for this. So that is, I am giving a name for the predicted variable as y hat, because your dependent variable is y. Y hat in econometrics means it is an estimated value, predicted value. That's why you should have to type predict a space y hat, comma, you are predicting y, okay, you are predicting y hat, okay, you are predicting y hat. So then once you have typed predict y hat from the last estimated model, and type that as like that in the command area and enter it. Okay, so once that command is executed, so to check whether it is really added to your work file or not, you go to again the data editor sheet and double click on that. So let us observe here, this is your estimated value, this is your predicted value. Actually the GDP of India or the income of India in 1950 was 91, but your predicted value is 181. So this is your prediction, or this is your predicted value, which is y hat. So this is the we have predicted based on our estimated model of ARIMA 110 model. So then also we should have to predict the standardized residuals of this. So that is the STDP. So STDP. Okay, that is one, you have to type predict STDP and enter it. Okay, that is the predict, it is predicted, okay, which is predicted, and also it is added to our file, that is stdp. This is the predicted value of the standard errors, okay, standard errors. So then uh, after saving the results of predict our estimated results, predict the standard deviation. So for example, you can draw a scatter diagram between these two variables, for example, in stata you have to type two-way for that two-way scatter diagram, a space L fit. That means we are fitting already fitting a confidence interval for this, that is L fit Ci, a space. After that we are fitting it for income and y hat, actual value and the estimated value y hat, okay, hat y hat. So then put a comma after this, then stdp, okay, stdp a space, okay, a space and two lines like this. So then we need a scatter for these two variables, that is inc and y hat, y hat. So now we have required a two-way for a fitted variables, in a fitted variables for inc and VAT. The original variables are the income along with the fitted variables. After this you just okay, not allowed. Oh, sorry, okay. So of course there is a mistake in this command. That is not the actual okay, symbol of this, actual symbol of this. So I don't know where it is. Okay, okay, okay. So now, okay, this is the confidence interval it is we have fitted. Okay, this is this area represent a confidence interval, but actually our model is not perfect, because the many values are outside this. Many values are outside this because I have taken only in a hypothetical one, that is I have not derive all types of variants of the ARIMA model. So this is the way which you can check whether this is your fitted, blue line is your fitted values, these are the actual values, this is the 95 confidence bond. So but most of your income variables are outside this. So then by observation of this 110 model is not appropriate. So then according to that ARIMA model methodology, earlier I have told you that, or I have shown you that, you go back to again identification, then repeat your procedure. Okay, this is the way which you can check whether your estimated values and the actual values are close or not. Because earlier I have told you that you have to do all these checkings, you have to do all these checkings or testing whether your model is validated or not. This is one kind of validation, because your model is not appropriate, because the many of your actual values of the income are outside this 95 confidence bond. Hence this is not appropriate. You have to repeat the steps thus far we have followed. So that is the point which we have noted here. Then the last but not the least regarding this is forecast. Okay, for forecasting, for example, you have to type like this. Again, you have to type predict. You have to type predict. After, give a space. And of course, here there is a static prediction, forecasting, dynamic prediction, and so on. So here I have shown you a dynamic prediction, So what we are requiring is that we need to predict our estimated value like this: y hat, y hat dynamic, y hat dynamic. So then put a comma, then type dynamic, and within the bracket for which year you needed that forecast. Example, here I have written it as for 2000, and for based on the original variable y, that is the income. So that's why I repeat, you should have to type predict y hat dynamic, and put a comma, dynamic within the bracket for the year which you are intend to predict. So then y. So you just press an enter button. Of course, not allowed. 1 minute. 1 minute might be. So y is not required. Yeah, the y we need not to be required, that y. So now the y hat that is predicted, and you go back to you go back to this. This is the predicted values. Okay, this is the predicted values. So like this, and once you have predicted this, again you should have to check the accuracy of this prediction by using different things or the different tools. Earlier I have told you like that, told you that. So that is of course I have not shown you like box Jenkins Q statistic or again running ACF and PACF for this. If all these are according to your expectation, then your predictions are accurate. Otherwise they are not accurate. Probably for this illustrative example, this is not, because this is not an appropriate model, as you're already seeing by comparing our estimated value with the actual values. So I think since it is all, we have crossed our time, 20 minutes more of our given time. So this is just the use of stata. So use the same procedure for estimation of an ARIMA model and also for the forecasting of ARIMA model. So with this, I think better to wind up my class. I thank you one and all for your patience listening from last almost 1 hour 45 minutes. So thank you one and all.
Thank you, sir.
If there is any queries, of course you can ask me in 5 minutes if there is a time given for me by the Rangappa sir or Uchaygoda.
Also.
ಏನಾದರೂ ಕ್ವಶನ್ಸ್ ಇದ್ರೆ ಕೇಳ್ಬೋದು.
Also.
If any participants have any questions, please raise your hand. I'll unmute you people.
Okay, one Anjali Jha is asking me regarding whether the penal data procedure is same. But generally it is same, but in checking for the penal data, you have to, of course, first there are different steps for stationarity or non-stationarity. They are called as penal unit root test. You have to use that penal unit root to test and make it your series as a stationary in penals. So then use the same methodology. The broad methodology is same, but your data is different. That's all. And even for diagnostic test also, you have to use the penal data related diagnostic test. Okay, which lag has to be selected from the AC and BAC is a one question raised by one person, APO 5, F5. So earlier I have told you that you should have to get AAC and AAC and BAC for every estimated model. That is variants of the ARIMA. And you have to compare AAC and BAC for all the models. And you should have to select a model which has lowest value of AAC and BAC. Okay, so let us assume that you have estimated 6 models with different variants of AR and AR and MA terms. Okay, out of that 6 models, you should have to select the lowest model, which has the model which has lowest AAC and BAC. That's all. Okay, Anjali Jha again asked me regarding the sample size and related problem of autocorrelation and the heteroscedasticity. That is not, of course, related to the sample size. Of course, we know that if you go through the problems faced by a type of data, for example, time series or a cross-sectional type of data, so that is that they are consistent. That means our OLX estimators are consistent. Even we have a large we have a problem of heteroscedasticity or autocorrelation, but the problem is related to standard error in both the cases. So then, is there any further questions?
Sir, in the chat box, a person called as Manali Manali wants a clarification.
Okay.
She's asking that, sir, please include some discussion about VAR modeling also.
But that that's earlier I have told you that the VAR model of forecasting is called as multivariate forecasting models. Okay. And of course, in Prem Kumar, co-integration related analysis to estimate that co-integration of box, that is the Jenkins, that is the Johnson multivariate methodology, that is purely based on VAR. So the VAR methodology was developed by, that is the vector autoregressive methodology that was developed by an econometrician named Sims from Minnesota University in US, against to the London School of Theoretical Econometrics. That means we have multiple equations, simultaneous equations. London School of Economic Thought or the London School of Economics given importance to theory in specification of econometric models, whereas American School of Economic Thought, specifically the Sims and his followers, so they given importance to the data in determination of the relationship and causality than the theory. Okay, that is the distinction between okay, the schools of thoughts in econometrics. So, and in case of London School of Economics related thoughts, even in running a simultaneous or multiple regression equations, you should have to specify every time a theoretical background to include or not to include a variable. Whereas in case of Sims methodology, so you should have to treat all variables as endogenous variables. I hope all of you are familiar with endogenous and exogenous variables. To classify that endogenous and exogenous variable is must in case of London School of Economic Thought related methodology. Or whereas in case of VAR analysis, you should have to treat all your variables as endogenous variables, run one variable on all the other variables along with their lagged values. So according to that Sims methodology, so what the crux of that is the best predictor, the best estimate of your chosen time series variable is the same. Earlier we have thus far noted is that, so the value of the past value of a variable and the past values of the other variables. So hence we need not to use any exogenous or endogenous classifications. Use all variables as endogenous and lagged values of those variables and predict the value of a dependent variable. That is the distinction between VAR and the simultaneous equations developed by London School of Economics.
Sir, here there are last two questions in a chat box, sir.
Okay, one is
Chetan,
Yeah.
that's the start.
prediction or studying relationship in variables, the base. Okay, of course, the ARIMA model is purely used for prediction or forecasting. But you know that without estimation, you cannot predict it. And that's why, of course, most of my discussion is related to estimation. And at the end, I have shown you with the, because of the paucity of time, the prediction related or forecasting related that. Because since it's an econometric methodology, so without estimating your results, you cannot predict it. So that's why in case of only estimation, your work ends there itself. But in case of prediction, so the estimation is a back steps to prediction. Back step to prediction means first you should have to estimate your parameters based on that estimated model and checking whether that estimated model is valid, then only you go for prediction. So I think that is related to APO 5, okay, F5 related query. Then one more is the number of the years of data. So of course there is no any unanimous opinion among econometricians to specify an exact rule of thumb to use the number of the years for time series analysis. So that is only 20 or 25, only 15 or 30. But on the average, the opinion is you must have to have more than 30 observations or 30 years of observations in case of yearly data. So that's why of course you should have to have as many as possible. That is as many as possible, as large. You should have to collect the information and use this time series models. Otherwise, if you have only few years, for 15 years, for 10 years, so your results are not at all related. Not at all accurate and also not at all valid. Yeah, of course, daily data, weekly data, monthly data. I hope in the next session will be related to the daily data, weekly data, and monthly data related to volatility. I think the Niranjan will give you answer related to that.
Thank you, sir. Thank you, sir.
Okay, thank you. Oh, Prem Kumar. Thank you, Prem Kumar. Thank you very much.
Sir, now, sir, shall we start now, sir?
Okay. ಹೇಳಿ ಪ್ರೇಮ್ ಸಾರಿ ಹೇಳಿ ಗೌಡ್ರೆ
Sir.
ಓಕೆ ವೈಂಡ್ ಅಪ್ ಮಾಡಿ ಗೌಡ್ರೆ ಸಾಕು ಈಗಾಗಲೇ ಬಿಕಾಸ್ 15 ಮಿನಿಟ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ಬಿಡ್ತು ಐ ಥಿಂಕ್ ನಿರಂಜನ್ಯಾಸ್ ವೈಟಿಂಗ್
Martesh.
ಓಕೆ ಥ್ಯಾಂಕ್ ಯು ನಂಡ
Okay, sir, just a minute, sir, please.
ಓಕೆ
Martesh. Sir, thank you, sir.
ಓಕೆ ಥ್ಯಾಂಕ್ ಯು ಗೌಡ್ರೆ ಓಕೆ
Thank you, sir. So for your wonderful, that so detailed explanation about this ARIMA model. So I'm forecasting. So thank you very much, sir. Thank you, sir.
ಓಕೆ ವೆಲ್ಕಮ್ ಥ್ಯಾಂಕ್ ಯು ಆಲ್
Okay. Either, sir. Chetan,
Yes, sir.
stay few minutes, So good afternoon, everyone. I hope you all are enjoying this workshop. So we are in the last day of this 7-day workshop. Finally, we have one more session of Dr. Niranjan sir. After this session, shall we have 15 to 20 minutes validatory function. I request the participants who want to share your feedback about this workshop. So please, so share your willingness in the chat box. So and in the future also we are planning to conduct different academic programs like this. So I hope we may expect the same cooperation. Thank you. So let's have a 5 minutes break. After this break we have Professor Niranjan sir. He is going to speak about that arch and grach model. So thank you everyone. Okay, we'll get back to you later.